For the single replacement lab, there are a number of things you must do before the lab to get the most out of it. You must summarize the hazards and procedures in your lab logbook. And you must complete the single replacement prediction sheet before you do the lab. So let me introduce you to some of the materials you're going to be using for this lab. This is a well plate, okay, and what it's designed for is to run really small scale reactions in these little wells. And especially when you're keeping up with a number of different reactions all at the same time, it kind of makes it nice to be able to see how they intersect here. So I've actually made out a well plate diagram here for you to help you figure out how to put the chemicals together and keep up with what's reacting. Okay, so if you take and lay the well plate on the top here, you can see that I've got it laid out for you to put your hydrochloric acid here and your magnesium nitrate here, and the magnesium metals go in these wells here. Notice that you don't need to put anything in this last column over here because I only set up this lab for 5 solutions and 4 metals. Got that? All right. Now, you don't need to use a lot of chemical. In fact, one of the things that chemists should try to do is to take care of the environment. We want to be good stewards of the environment because we only got one. We mess it up, it's gone. Okay? So we want to try to take care of it so we don't use any more chemicals than we need to for this lab. So what you want to do is take small pieces of metals, okay, and put them in there, and only cover those metals with enough of the solutions that you as are needed to see if there's a reaction or not. Okay? So now some of the metals you're going to have will be in strips, and you'll have to cut little chips off. Some of it, like here's a sample of copper, for example. You don't need the whole thing. You can take a pair of scissors and cut a small piece off like this, and ball up just a little bit right here, and coppers go in that column of stuff right there. Does that make sense? And so we're going to, if we react that with zinc nitrate, the zinc nitrate are in little squeeze bottles like this, okay? And so you're just going to put enough drops in there to cover that copper to make sure that you can see whether there's a reaction going on or not, okay? So what you're doing is recording observations to see if these observations meet with or refute what you predicted were going to happen. Now, some of the metals are going to have, if they're not shiny, now zinc, you won't have to worry about it. It comes in chips, so don't worry about that. But things like this magnesium, it's kind of shiny, but just to make sure, every one of these lab tables is supposed to have, I had one here a minute, there it is, a small piece of what's called emery cloth, which is kind of like sandpaper, only it lasts a lot longer. And you just want to make sure you shine up one side of it. Okay? Anything that looks like it doesn't have a shiny side, can you see how I shined up just the end corner in right there? And so you just need a tiny little chip right there to drop in there. Okay? That makes sense to everybody? And all these metals are thin enough and soft enough that you can cut these with a pair of scissors. And then you're going to make your observations, and you're going to complete your observations, record those observations very carefully, keeping up with what's reacting and what isn't reacting in your lab logbook. And then the post-lab is to go on Google Docs, find your folder for this class, and there's a document in there now for the post-lab. Okay, and just fill in the post-lab from your notes in your lab logbook. Of course, that's the homework. The part you do on Google Docs is homework. Any questions? Yep.
Do we take this back there?
No, that doesn't go back there with you. Okay.
So we would do the second part of our chart later.
Yeah. You can finish. What you can do today in the lab is simply record your observations. Okay. Then you can come back and look at your pre-lab sheet and say, okay, I predicted this would happen. Look at the observations and see, well, is that what happened? So that's it. What is that? That's making you do if you're going to do a good job with this is make good observations. Okay. You want to make sure that your observations are clear and understandable, so that when you go back and compare what you predicted would happen and why you thought it was going to happen to what you actually saw, you can either verify or refute your prediction.